Hello, I'm teacher Ivan from WUNNA Educational Services, also a teacher of physics at Angel High School, Namaswa. Please enroll with us at Angel High School, Namaswa, so that you secure your future, majorly in the sciences. Today we are looking at significant figures. We call them significant because they are more important, or they are important figures. And under significant figures, we shall learn about rounding off and the scientific notation. However, before we look at how we round off or how we write in scientific notation, let us first look at how do we determine the significant figures? There are rules, majorly 4 rules, that we use to determine significant figures. The first rule says that all non-zero digits are significant. When we say non-zero digits, we mean from 1 to 9. So from 1 to 9 are all significant figures. Then we have what we call the trapped zeros. Trapped zeros are significant because they are between the non-zero digits. For instance, we have 102. Since 0 is trapped, it is significant. So these are 3 significant figures because the 0 is trapped, and since it is trapped in non-zero digits, it is considered significant. So that is our second law. When the 0 is trapped or embedded within the non-zero digits, it will be considered significant. Moving on to the third rule, we have the trailing zeros. The trailing zeros that are as a result of rounding off are significant. For instance, if I have 1.998 and I want to round off, because these are non-zero digits and therefore these are 4 significant figures. But if I'm to round off, let's say to 3 significant figures, once I round off this, I will get 2.00. And now, since the zeros are as a result of rounding off, therefore they are considered significant. So this one is 3 significant figures. So the trailing zeros that are as a result of rounding off are significant. That is our third rule. Then to continue to our fourth rule, it's where we shall consider the zeros that do not set decimal points. Those ones are not significant. For instance, such zeros that do not set decimal places include, for instance, we have 2.50. This zero is not significant because it does not set the decimal place. So those trailing zeros, or even they can be preceding zeros. For instance, 0.0125. Here we shall only have 3 significant figures. These zeros are not significant. And this 0 is also not significant. So those are the 4 rules of determining the significant figures. Otherwise, we shall also look at how do we consider the significant figures during multiplication and division of values? During multiplication and division, we shall consider the significant figures of the number with the least number of significant figures. For instance, when I'm multiplying, this is 2.5 times 0.135. This one has two significant figures, and this one has three significant figures. So the law says that my answer should have the same number of significant figures like the one with the least number of significant figures. So the least number of significant figures is 2, meaning that my answer should be to 2 significant figures. That is the law of multiplication. However, it also applies to division. If I'm having, so mean that my answer here should be to 2 significant figures. Then if I'm to divide, that is to say, that is 125 divided by, let's say, 15. 125 divided by 15. This one is 3 significant figures, and these are 2 significant figures. The same applies just like any multiplication. So that means that my answer has to be to 2 significant significant figures. That is for multiplication and division. The answer should have the same number of significant figures like the one with the least number of significant figures in those that you are multiplying or dividing. Then for addition and subtraction, we don't consider significant figures, but we shall consider the number of decimal places, such as, for instance, if we have 1.25 plus 1.5, when working out the additions, we shall consider the number of decimal places of the values you are adding. And the law says that our answer will have the same number of decimal places, just like the one with the least number of decimal places. So this one has 2 decimal places, and this one has 1 decimal place, meaning that our answer should be to 1 decimal place. That is the law of addition, which also applies to subtraction. The same applies in subtraction. That is to say, if I have 2.706 minus 1.75, so this is 1 decimal place, and these are 2 decimal places, and now my answer should be to 1 decimal place. So that is how we do the addition and the subtraction. Otherwise, let us look at how to round off. How to round off? We are looking at rounding off. How do we round off? The approach is simple. During round off, when the value are rounding off is less than 5, let's say 4, you don't add a 1 on the next. For instance, if we have 0.134 and we are rounding off to 2 decimal places. These are 3 decimal places, but we are rounding off to 2 decimal places, meaning that this one will be rounded off, but since it is less than 5, we shall add a 0 plus 0, and this one is taken to be 0. So meaning that we shall have our answer as 0.13, and that will be our answer to 2 decimal places. So when rounding off, look at the figure you are considering. If it is less than 5, add 0 to the next figure and drop this. If it is 5 and above, we add a 1 and drop this. For instance, if it was 0.135 and we are rounding off to 2 decimal places, just like this, we could add a 1 and drop this. So that gives us 0.14. This is to 2 decimal places. That is, if it is 5 and above, from 5 to 9. If it is 4 to 0, we add a 0 and drop the figure. That is how we round off. We also have another term, that's truncating. During the truncation or during truncating, we just chop off. We don't add. For instance, 0.136. If we are truncating to 2 decimal places, we shall chop off the 6 and write 0.13. That is truncating. We don't add. So that is how we do the rounding off. Then lastly, as we summarize, let us look at how do we convert the standard numbers to scientific form. So, assuming we have our number as 0.0125 and we want to write it to scientific form or scientific notation. First of all, what's the importance of writing numbers in the scientific notation form? That helps us to express very big values or very small values into a simple number or into a simple form. For instance, if I have 0.00056, this is a very small number, almost 0. So if I want to express this in a simple way, I will use the scientific notation. And the law says that we express it in form of A times 10 power n. And that means that when expressing this number in this form, we are going to move our point towards the right until we meet a non-zero digit. That is to say, this is 1, 2, 3, 4, 5, 6. So our point will be there. And that will give us 5.6 times 10 power. We now count how many steps have we skipped. This is 1, 2, 3, 4, 5, 6. However, when moving from left towards right, we indicate a negative on our power. So that means that it is power -6. Then, if we are moving from right towards left, for instance, if we have 1000, 250. And you want to write this in scientific notation. That means that we don't have a decimal point in our figure. That means that we can put it at last. And therefore, we shall move it until we are left with one non-zero digit on the other side. So we shall move our decimal point until we are left with one digit on the other side. So that gives us 1.25. We can drop the zero because the moment we introduce a decimal point here, this zero becomes useless. But we maintain the number of steps we have moved. So that is 1, 2, 3. So that will be times 10 power 3. D3 is positive because we are moving from right to left. That is positive. From left to right, it is negative. That is how we write numbers in scientific notation. We shall have examples and even trial questions in our next video. Otherwise, for now, that's what we can discuss about significant figures. However, we shall have more videos concerning the same topic so that we can grab the concepts easily. Otherwise, I'm teacher Ivan from WUNNA Educational Services. Bye bye.